you, everyone, and welcome to Act 2 of FutureNet. We're living in a world where cars can drive themselves, drones can fly themselves, and everything is getting autonomous and more intelligent. With the growing complexity and scale of our networks, it is time for industry to enter the era of self-driving networks. Hi, I'm Stephan Massalt, and I want to welcome you to this panel on virtual networks, the pursuit of Autopilot. In the next 35 minutes, we will take you through a range of different topics with the four members of this panel. Let me first ask them to introduce themselves. Truman.
Hi, I'm Truman Boys, Senior Vice President of Infrastructure for Major League Baseball, basically bringing baseball to the fans.
Greg.
Hey, I'm Craig Connors, VP and CTO for SD-WAN and SASE at VMware, building next-generation self-healing networks.
Bikash.
Hi, my name is Bikash Koley. I'm the VP and Head of Global Networking at Google and Google Cloud, connecting everyone to Google.
Dave, last but not least.
Hi, I'm Dave Ward. I'm the CEO of PacketFabric, which is a network as a service platform delivering real-time on-demand internet. But in this drama, I'm playing the hardware guy.
Well, then let's start with you, Dave. Just starting at the bottom of the network, as you said, the hardware. There are lots of new developments, smart NICs, smart switches, offloading, acceleration, etc. Do we need to reconsider the trend of putting everything in software and just go back to the old hardware?
Well, let me put a plug in for the hardware. This is the golden age right now of networking and compute infrastructure. We have the most powerful compute. We have the most powerful switches and routers. We have the longest reach and most powerful optical interfaces. We have the rise of smart NICs. But really what this means from a hardware perspective and an internet architecture perspective is that devices, hardware devices, and therefore other modules of it are being built for a functional purpose and a functional location in the internet. And so as the internet architecture evolves to deeper and deeper into the edge, you're getting more and more variations of extremely powerful hardware.
It looks like Bikash is completely agreeing with you. Bikash, what's your response to that?
Look, hardware is obviously very important, but so is software. To me, hardware and software for networking, they're just implementation choices. What I actually do care about a lot more are the principles that are followed in designing network as a system, right? And there are really three principles that I have always believed to be the most important ones to ensure that hardware and software are interchangeable or, in fact, the line blurs. And they're really clean separation of data control and management planes, open declarative APIs and data models that completely describe each of those planes, and finally, intent-driven operation. Now, why are these three principles important, right? Let's use an example. Let's say I have implemented a certain network function in an NPU today, and tomorrow I want to implement the same thing, let's say in a cloud implementation, where it's either in a next-gen NIC or maybe even in a software implementation. Now, if I used a very cleanly defined open API for the data plane, let's say P4 or P4 runtime, or maybe eBPF or XDP, the data plane is actually interchangeable. I can keep my control and management plane exactly identical when I move this function from a hardware-based implementation to a software-based implementation. You could say the same thing about the management plane. If I did the management plane implementation using things like OpenConfig, GNMI, GNOI, it doesn't really matter so much what is the underlying implementation in terms of physical or virtual. End of the day, you need both. End of the day, it's a function of economics more than anything else in how you implement it. But it is important that the design itself allows you to use them interchangeably or blur the line as you need to.
So that sounded great, Bikash. But look, as the token hardware guy on this, you have to realize that there's some things that can be done in hardware that can't be done in software. And that is tens of terabits per second of flinging packets. It's not an either or specific implementation choice. I just want to refine, maybe disagree with what you're saying. It's an implementation choice on a position and function and network of what you're trying to accomplish. And you have to be able to have the design pattern of splitting between the two based upon the function you want to do.
I don't necessarily disagree with you. I think it's more a question of what are you programming? Like, I would argue that every hardware ultimately is a target for programming. An NPU use a programming language, so does a NIC. So I think the more important part here is, are we choosing the right programming model and the right way of programming it? And then, I don't, again, disagree with you that for some functions, hardware is just better. It's just going to be more economical and more performant to implement it.
If I could jump in here. Yeah, what I want to say is I think that what we end up seeing here is that software has really challenged the hardware world. Being able to program hardware has usually been out of the reach of most of enterprises and even large entities because of the proprietary nature. And what we've kind of seen here is that open standards and open source and basically innovation happening within the software world has challenged our model of thinking. And now we're seeing that whether it's P4 or other domain-specific languages that exist within the hardware world, that they're starting to evolve and take some land. I think it's actually, just to take an optimistic view of this, is that software and hardware are coming together and challenging, both areas. They're starting to, continue to open up this possibility that anyone can consume it and have either fast data planes, fast control planes, and secure programming frameworks.
Yeah, I think, hardware is always going to have a role, to Dave's point, in the multi-terabit forwarding world. That's not most customers' use case. And for most customers, our networks are becoming more and more agile. Things are changing faster and faster and faster. And having to respin an ASIC every time I want to support a new protocol like Quick, that's not going to work, right? And so software is giving us that agility to keep up with the pace of changes that are happening in the world. And it fits the speed with the advances in hardware that Dave talked about, faster CPUs, hardware offloads for crypto. It fits the needs of most of our use cases.
So careful, Craig. So most customers not needing multi-terabit, not gigabit. I mean, take a look at the hardware that's being built. It's like 10 terabit per second chips, 12 terabit per second chips. That's what's being sold right now. So it's, again, a function at a position in network that requires this. And leveraging off what Bikash said, almost all of these devices are now programmable. And so I'm not going to fit into that box where I've got to spin an ASIC every time I want to do something new. That's not quite the way the world's working right now. It's really putting together a systems approach, which is a word that Bikash didn't use, but really what he was describing, of really trying to build out the entire service and having the right device, which also could be a software appliance, at the right position, at the right time to be able to do what you want, such that Truman can deliver baseball to my eyeballs. And to be honest, I don't care how Truman does it. And I know it's a combination of hardware and software, and it's cloud, and it's, I'm sure, private data center and all sorts of stuff, Truman. And I love it. And that's really what I'm interested in. And Truman, I hope that's the way you treat this infrastructure as well.
Yeah, I think, Dave, what you positioned here is a really interesting point in time. This reflection of what actually happens with this model that we've been embracing for the last 15 years, which has been scale out. Scale out is really a reflection of software scaling, because we haven't had the ability to have this oscillation where you pull back into hardware to get that leverage. So, I think we're continuously going to see this movement between scale out and then contract. And so whether that's centralization or just distribution of function, software, hardware, I think we're kind of seeing that they're both beneficial. But I agree with you. If the net result is that we can deliver awesome quality, high video games, I'm happy.
So what's interesting to me, and Bikash, I was wondering if you could help here. I laid out, I kind of, pulled the pin and threw the grenade on the economic value of flexibility. And it's really a difficult question in the industry today, whether or not it's economically viable to have virtualized network security storage functions or containerized, depending on, it doesn't matter how you actually package it. Is it possible to get the density on a compute platform such that there is a very high value for flexibility, meaning that you can switch what you're running on a compute at a position in a network in real time to be able to deliver a service? Or are we still on that crux where you think we need specialized smart NICs or accelerators or crypto chips that Craig alluded to?
Yeah, I think compute is going through sort of the same transformation that networking has gone through in the last 30 years. In the very early days, routing was done in general purpose processor. Then it went into NPUs because it was a lot more efficient, special purpose for processing packets, right? You see the exact same thing happening in virtualization of networking as well, right? The first try in virtualization was software implementation of hardware functions historically, right? Things like OpenFlow and P4. Increasingly, a lot of those implementations are going to happen in SmartNIC accelerator, right? And if you ultimately look at what the SmartNICs are doing, not that different from what NPUs did in the large boxes. You're basically doing special purpose implementation of optimized hardware to really offload some of these functions, which you do very often with every single packet, right? So what we're actually going to see are that there are some functions that are done repeatedly and they're reasonably straightforward, but they don't need general purpose compute. And increasingly, they'll be offloaded with things like SmartNIC, with things like DPUs as they get implemented. End result is still, going back to Dave, your original point, programmability. How do we program the system? How do we do it interchangeably? And use the best tool that you have for processing those pieces of bits that you need to process. So that's where we're going, I believe.
So interesting with virtualization, Craig, if you don't mind. So another virtualization of networking and hardware is plates of spaghetti of tunnels. And you're a tunnel guy now. And I was wondering, do you see this as trying to overcome speeds and feeds and create flexibility so people can do cloud on-ramp? Or how does network virtualization fit into this whole picture on your reliance of needing to have fast forwarding of bits and location of those services?
Yeah, I mean, Truman mentioned scale-out architecture. You look at modern Intel CPUs, we can do 13 gigs per core of IPsec, 14 gigs per core of TLS, iMix in software without even getting into SmartNICs, without even getting into Quick Assist and other hardware offloads. And so we're able to do a lot just scaling out horizontally those services. And if you look at what we're doing today with SASE, it's exactly what you talked about earlier. Can I take a pool of hardware resources and can I deliver different types of services and can I change them in real time? Yeah, we can swap out SD-WAN functions and cloud web security functions and secure access functions in real time on that same pool of compute, delivering these things in high speed in software. Now, is it backbone routing speed? Not yet, but hardware's moving pretty fast. So, we're a lot faster than we were a little while ago. Now, with those per core speeds and with scale out and with the agility it gives us to swap components in and out, I think that virtualization flexibility is really key.
Dave, what I wanted to add was, when talk about virtual networking, any concept in virtual networking, I mean, I love networking, but I always question every layer. And it concerns me that sometimes there's abstractions that we take for granted. We assume that, closed user groups of VRFs and routing tables is isolation that provides value. Now, it may in an implementation standpoint, but there are other ways to, affect this idea of closed user group and security and the benefits that are implicit in that. And so my concern on virtual networking, whether it's a tunnel or it's a label or it's a something that you have to pop off of some end cap, is what is the value on every time that I'm adding something into the infrastructure? What am I getting, and how much more complexity am I going to add to this whole stack of environments? So I challenge the idea of virtual networking as a whole. If we believe that the truth is that VLANs and IP addresses and all these things that are somewhat transient or ephemeral does the same rule apply to VRFs and closed user groups and other types of routing isolation? So I just kind of leave that there as like they have a place, but I am concerned that the industry has taken these as like the broad brush way to achieve security.
I think the point that you're making is that networking is exposed with the wrong abstraction to those who use networking. When your developers write the next MLB app, they actually don't care, the VRF or whatever is the underlying technology that forwards the packets or completes the session or manages the session statefully. I do believe it's actually, the debate is not whether it's physical and virtual. They both have the same sets of layers and complexity. The debate is really the programming model and the abstraction by which you expose networking to the outside world. Underneath, there could be complexity, and a lot of those complexities are because you are implementing things that are complex. But most users of network actually couldn't care less. I mean, they really want the network to be invisible. How do we step up and create that next level of abstraction, which are mostly policy, actually? They're not even, how the forwarding plan works. And I think that's where we need to go.
So a couple things. So first of all, I pretty much agree with both Truman and Bikash, because whether it's VRFs today or NAT tables yesterday or whatever the case is, this is exposing an IP address management problem from the guts of the hardware all the way up to the top level IT enterprise engineer. And whether you're trying to connect multi-cloud and there's overlapping addresses, that's really you're trying to solve an IPAM problem to a degree. But before we jump to the network as a platform, which I am itching to get to, what I do want to mention, because Truman, again, laid a bear trap, and he might have laid it for me, I'm not sure, but he said, we're confusing the layers of the network, and we're confusing the layers that we're abstracting. And what's interesting about this, with the virtualization of the network, via tunnels or via whatever mechanism, there is a dependency of optical to L2 to L3 to compute and virtualization. And that recognition of the dependency of those layers, I think, is being lost in the industry today from a programmability and from a management point of view. And I say that because a tunnel is a beautiful thing to get you to cloud very quickly, but it's a terrible thing if you want to debug it and find out where something's going wrong, because it is completely dependent upon the layers underneath. And our desire over the last 10 years in the networking industry to be able to quickly mesh, merge, or skip layers without having understanding the dependency between them, to have a service level agreement. And really what I mean is, Truman, you need a certain amount of bandwidth with a certain amount of latency max, with a certain amount of jitter to deliver baseball to my eyeballs. And if you just use an overlay tunnel going into an appliance sitting on a computer, you may not have that level of service that you need to deliver it to tens of millions of eyeballs or hundreds of millions of eyeballs for the latest baseball or sporting event that you want to do. That, I think, is a tragic miss in the industry of the dependency of the layers.
Oh, Dave, I completely agree. I think we haven't had the tools, or maybe the industry has just kind of jumped over and thought about these specific technologies that exist within our domain, versus this idea around expressing intention or expressing capabilities. So there needs to be a consumer. The consumer is the application, and the application needs to know what are the units of measurement on how to consume the given resources of the network.
And I do think it's been a failure, actually, of standards bodies and open source not to begin to expose bandwidth, latency, jitter, just some of the biggest building blocks of networking, and have an orchestration layer, or whether it's OpenStack or it's a container-based system that allows an application to actually request those resources. Right now, in the magical cloud, remain calm, Bikash, in the magical cloud, the internet is ubiquitous and infinite. And that is not a great assumption when you're talking about mission critical services or bandwidth, latency, or jitter constrained services.
Well, I would say that cloud does get you one step closer, and I would fully admit we're actually not in the unit of networking that most applications care about and selling that as a product, but we're making progress there. I think the biggest problem, Dave, in the networking space has been those who develop networking technology and those who offer network as a service historically has been two separate sets of entities. And as a result, what is ultimately offered to the end consumer of network has not been optimized in the way that the technology abstracts itself, right? Which again, network as a service or networking as part of a service, start addressing that, because you don't anymore care about how when you connect to Google Cloud, there might be 3 layers of abstractions and tunnels that is hidden underneath that are actually not exposed to when somebody is consuming cloud or cloud connectivity. What you're really getting is an SLA with bandwidth and maybe your peak burst rate, as an example, right? So I think we're making progress in that direction. It's not something that is as standardized as it really should be. And it does need, focus as an industry as to how we express network better, not as implementation, but as a consumable resource that users and applications care about.
Okay, Stephan, I'm not the hardware guy anymore. I'm not going to be the hardware guy anymore. I've got to talk about network as a service.
I'm trying to give you that opportunity, Dave. I'm trying to give you that opportunity. Don't worry. So taking that angle from let's say the developer perspective. So we went up from the hardware layer. Let's take a top-down look now into the network, and because you brought it up already a little bit, in software land, developer land, it's all about microservices and looking at these agile DevOps principles. So maybe Greg, you can say a little bit about it. I mean, are we already to the point that our networking teams can just apply these same principles on the world that they work in?
Well, I think we're getting there. I mean, Dave mentioned loss latency and jitter and how important they are. And I think we can have a whole separate panel discussion about industry standards versus proprietary solutions. And obviously, I have a biased opinion on that. But I think if you look at what we've done in the SD-WAN space, we've already abstracted away a lot of traditional networking functions that 20 years ago, when I started my career in networking, things I was doing, writing WAN QoS rules, writing traffic steering policies, setting up, backup connections to provide resiliency, all of that's gone now with SD-WAN. The vast majority of our customers aren't configuring QoS policies. They're taking smart defaults that come out of the box. They're delivering a solution. They're letting the system manage itself. It's monitoring the loss latency and jitter. It's identifying the applications. It's mapping them to SLOs, and it's steering the traffic the way that it thinks it should, and then providing with analytics feedback about whether the system's doing a good job or not. And now if you think about what I need as a modern application developer, that's very close to my nirvana state, because what I want to do is I want to tell you, here's an application, here's the people who can access it, and here's the SLOs to make the requirement. And all I want to do as an application developer is that, and let the network figure the rest out. And yeah, to the Bikash's point, maybe there's a tunnel under the covers. I don't really care. I don't care how the software does it. I care that I said the app's in Google, this is the SLO, this is who can access it, make it happen, and the software does.
I feel that there are always going to be people that want to drive the car, people that have to fix the car, and people that sell the car. And I think the same rule applies within the networking world. Those developers don't want to know anything about the underlying infrastructure, and nor should they, because the point of this is to get the infrastructure out of the way. What we're providing, what my team provides, and what many other infrastructure teams provide is a straightforward way to consume the services so they can rapidly build applications.
So adding to that, Bikash, we're talking already about cloud and on-prem, but the biggest new development that we're seeing right now is that the pendulum is going back to decentralization and edge. Do you expect that these developments will have a significant impact on how we manage our networks, or?
Yeah, for sure. Anyone who has built consumer application in a Truman's company obviously does that. My company does it. We have always tried to push compute and data in the most optimal way for what our customers are actually looking for. Like, if you have used Google Search or Google Map today, you are most likely served from one of our POP, one of the 140 or so POPs that we have globally to reduce latency to tens of milliseconds. Interactive gaming, Stadia in our case. It has always been the case that compute and storage to some extent, to the extent that it is necessary, has been pushed as close to the consumer as we need. There is a cost to it, obviously. Generally, what you would find is that the cost of compute grows exponentially the further away that you go from the centralized mega data centers. Not just because of the economy of scale, but also the cost of managing them in a distributed way, right? So there is cost to be paid. The most interesting thing in the conversation in Edge that I believe get lost is not the software component of how Edge Cloud is turned up. It's important, but the really important part is when you have thousands of locations around the world, which I have some experience in operating for over a decade, things break. And 1% server outage all of a sudden becomes things that are breaking every single day. So if you're not starting with, again, going back to the theme of this session, if you're not starting with automated and hopefully autonomous at some point in mind, where a failure creates an automatic repair ticket and repair happens, you cannot scale it. Separation of control, data, and management plane, going back in the previous section, becomes critically important, because you might be deploying a one rack unit mini server into a cell tower location. You clearly cannot run your heavy control and management plane in that location. But unless you have designed it in a clean way, you cannot take it out and put it in some sort of centralized locations, right? Latency, speed of light latency is something that we talk about a lot in the industry. Now, the part that we forget is the last mile congestion is going to be there. no matter what we do. So it is not just reducing, and latency is not just speed of light. It's not how we reduce the speed of light latency, but what do we do with loss tolerant transport like QUIC? How do we do it very smart load balancing so that you can detect those network congestions and actually react as a result? Again, going back to the idea of autonomous network becomes so important for edge, both from infrastructure management as well as application delivery point of view. And I think edge is here to stay.
So it's safe to say without automation, the scale of edge is not manageable anymore.
That is correct. Yes.
Well, Dave, you've been waiting for your turn now. What is your response to that? It's of course different.
It is, and really the target or goal I have now with networking is building a real-time on-demand internet where the entire network is just presented as a software platform. So network or network as a service is delivered as a SaaS model. And there are just APIs where I can say, I want this much bandwidth between point A, point B, or multiple points. This is the latency, this is the jitter. Just deliver that to me. That a programmable internet that delivers the bandwidth, latency, jitter between the sites of connectivity that you want. That's the way hardware should be presented to folks. Just to disagree a bit with Bikash, underneath that platform, if there is or isn't a separation of multiple planes, customer got the connectivity they want. And so just like in any SaaS platform, there is a lot going on, like in a cloud, like in your cloud, there's a lot going on underneath that as consumers, we have no idea what you're doing and if there's a proper separation of planes. Now, a good design pattern for engineers to be able to run this underneath it, of course, is those separations, as you mentioned. But exactly what Truman wanted, which is, I need this much bandwidth right now between these points or multiple points, and I'm only going to use it for 5 hours and then the baseball game's over, and I only want to pay for it for 5 hours. I don't want to nail up this connectivity and buy and own. I don't want to own, manage, operate all this hardware from all these parks 365 days a year, because it's not what his business is. Let's face it, there are very few businesses out there where the intellectual property of their business is owning, managing, and operating a network or infrastructure. And Bikash and companies like Bikash's have presented RAM, CPUs, and storage as a service. What I'm working on now is presenting the network as a service. Craig is trying to say, great, if you can connect into these clouds and have this network underneath it that can deliver the bandwidth you need to all of these different places you want to go, I want to be able to have a button pushed on top for the consumer that allows them to instantaneously bring them all together. And if we can get there, the new notion of enterprise productivity as a service or IT as a service, that's kind of the nirvana that I want to see the industry head towards. And I'm taking the network as a service and network as code as my role going forward.
Dave, I agree with your statement that network as a service is ultimately what the consumers, the application developers and the consumers need. I would expand the definition of network from your definition. I would basically say application delivery and the mechanism for application delivery is as much a part of network as a service, and that's where edge becomes important because I would argue that load balancing is part of networking. But agree in principle that it's network underneath is too complex for most corporations to build and manage anymore. And for them, they just need an infrastructure to work. And so the future is absolutely network as a service. It's just which layers of network we offer.
I think Dave and I are solving similar problems, if I can jump in. I mean, early last year, we showed a demo of 5G on-demand network slicing where from our SD-WAN platform, I request a video slice, it gets provisioned into the underlay, I use it for the duration of the call, and then I give the slice back, right? To show the power of this on-demand networking. But there's not an infinite pool of resources there as well. I can't always request everything I need. And sometimes I have to work within the boundaries of what makes sense from a budget perspective. I'm sure Truman's budget for networking is much bigger than mine for my team, for instance. So I've got to work within the budget of what I've got. And sometimes I've got to take the resources I have and make them as good as possible for the connectivity that I have to achieve to be successful for my business. So I definitely think there's a place for network as a service, for network on demand. But at the same time, best effort is going to exist in a lot of places for a lot of people for a long time. And how we make best effort networks business grade is going to continue to be important as we deliver these models.
Of course, there's a full continuum of economy and economic scale there, but you're at one end of it, which where for your, I'd imagine for your capture, you need a very, very tight SLA, but for the eyeballs out to consumer, maybe you've got a different architecture.
Yeah, I think what I would say is the best effort has actually driven the demand with all these OTT services, which has allowed all of us, including enterprises, to benefit. Whether it's just cost of meg or gig per second, but also just this idea that there really is a substantial amount of capacity in the internet as a whole, more so in the developed world. But I think that the implication here is that we have a massive amount of potential. From an optimism standpoint, I'd say that applications now can consume so much more because the resources available to them on the kind of layer 1, layer 2, layer 3 are substantial.
The main thing that I think we're really all agreeing on is if you're not able to do it in software and integrate APIs to do it, to build your service, you're probably doing it the wrong way.
So with that statement, last question for each of everyone. How far away are we from a truly self-driving network? Dave?
It can be put together today, but it's really at the tip of the spear. So I think that the notion of self-driving all the way from application, all the way to edge, from capture, from eyeball to eyeball in Truman's world, from capture to watching, that we're now just building towards that, and the tools are available, and it's to be rapidly emerging. Most likely in the next couple of years, it's going to be the thing that drives the entire internet industry.
Yeah, I agree with Dave. I think in addition to advancements in technology that we're making, we have advancements our networks themselves are making. So what we've built with Edge Network Intelligence at VMware detects anomalies, surveys the surrounding network conditions, tries to apply error correction to resolve those automatically, uses reinforcement learning to determine whether it did a good job or not, and learn over time how to better fix problems that are on the network. So in addition to technological advancements, our algorithms are going to reinforce their own decisions over time to get better and better at mapping symptoms to problems and fixing those. So I think over the next couple of years, we'll really see a wide adoption of this self-healing concept.
I would say in some form, it already exists today. We talked about software-defined edge called Espresso, where we utilize application behavior to run an AI model to determine what's the best way of serving those customers. So it's a closed-loop system that is constantly improving in what it does. I would say the biggest challenge that networking has today in really truly being self-driving is in the physical layer, and by that I don't actually mean optical. I mean, how do you go and self-repair and self-heal a network? Somebody has to still create a repair ticket and do RMA and replace physical stuff. To me, the nirvana is when our router breaks and the repair happens automatically. The system creates all the things that it has to do. We have made a lot of progress, by the way, on the edge side on that front as well. But are we completely there? Not yet. We're making progress.
And Truman, you as the voice of the customer here today, how far is it away from your perspective? What do you need to get this done?
I think we are mentioned, we are closer to the tip of the iceberg. The challenge here is that while we do have some automation and some self-driving awareness, I think we're still running through some stop signs. I think that, we're at a point now where there's systems that need to be tied back in. We need more feedback loops, but the tools are starting to emerge, and we're starting to see more APIs that we can talk to. So we can build these loops back into our system so that we can kind of tie things back together. And I feel like it's probably within the next 18 months to 2 years.
Thank you, everyone. That was a great and lively discussion. We had a lot of topics covered. We agree on a lot of things, and we still have our differences. Appreciated your time, and thank you for listening.